everybody. I'm Michael Simo. I'm a platform engineer at Honeycomb, and today I'm going to be giving a talk going over instrumenting Honeycomb into dedicated game servers, and then gaining insights and seeing what problems you can find, identify, and resolve within the infrastructure. All right, so let's get started. So the talk is titled Insight into Instrumentation for Dedicated Game Servers, and a bit about me. So I've been in like the system administration, cloud DevOps space for about the past 8 years. And then as of the past 5 years, I've been using some more modern technologies like cutting edge like infrastructure as code, so Terraform, and then Kubernetes as a container orchestration platform of choice. And then I run a bunch of dedicated game servers on that platform itself. So some of my experience with game servers is I started around in like 2008, doing a third-party self-hosted game server website. I kind of like purchased a game server through there and then maintained it through like having an FTP connection, tunneling into the system, uploading files manually. It's very more archaic, I guess, compared to what we can do now. Later on, I started self-hosting game servers on Google Cloud using Google Compute Engine and then using some of the container resources they had there. So I built a Docker image and then I shipped it and then I hosted it myself. And now I've kind of taken that to the next step. And as of 2019, I've been doing all of my workload on Kubernetes. Everything's containerized, and I have a CI/CD pipeline where I can deploy servers and like get the newest version of them up pretty quickly versus doing everything manually through files. Everything's pre-built and then shipped off. So we'll be going more into that during this talk. So here's the roadmap for the presentation. We've got 4 sections here. First one's just going to be going over server architecture. Secondly, we're going to be going over how to add Honeycomb so you can send your metrics about your Kubernetes cluster to Honeycomb. Third is going to be my CI/CD process for deploying servers. So once I have a change that I want to deploy to the cloud, how does it actually get there? What are the steps that it takes? And then lastly, we're going to be observing some of the data. We're just going to do kind of like a rudimentary, brief, like basic view of some of the metrics that we're collecting from the Kubernetes agent. And we'll delve into that now. So server architecture, really excited about this. This is showing how the game servers are kind of deployed and then what components are involved. So 2 prerequisites. I'm using Kubernetes as mentioned earlier. Kind of some of the reasons that I'm using Kubernetes is because I wanted to learn more about container platforms and just how all the various components interconnect. So I'm using like stateful sets, services, and then I have some other networking components in there. I wanted to see how compute network storage can all be accessed from one location. So Kubernetes, given that has all these resources to allow you to interact with those types of components, it was a pretty good all-in-one solution for me. And then I wanted to go with the cattle, not pets approach. So instead of having your specific VM or server that you kind of like feed and you like very carefully, meticulously curate, I wanted to have more of like a dynamic workflow. So I have something that's pre-built and I can restart, delete, recreate, spin up, spin down resources, and I'll have the same output instead of spinning up a server and then configuring it manually, taking care of that manually. I just wanted to kind of automate that process. So I went with Docker. So I had the Docker file that kind of bootstrapped that operating system image into place of me kind of taking the pet approach. So cattle's not pet is the approach I wanted to take here. And then my second use case is my use case for Honeycomb. So previously, I didn't really have good insight onto how I could figure out what was going wrong. I just had logs from the server, and that was really about it. I had to use like Kubernetes events as well to see what was going on in the container platform, but those can be pretty basic. They're not super in-depth. So I wanted to extend that. So I used Honeycomb's Kubernetes agent, and then this allows me to collect various metadata from the Kubernetes cluster. Provides me with searching capabilities for all my labels. And then I get other information about like Kubernetes resource status and some other interesting data that I'll go and delve into later. Cool. So this is kind of the architecture for my game servers. I'm going to go briefly over the diagram on the left, kind of breaking this down, and then we'll go over the data flow on the right side. So let's just start with users, right? So a user connects to one of 2 things. They either connect to a website or they connect to a dedicated game server, which can be of several types. If they connect to a game server, then kind of the game servers are constantly talking with the Kubernetes collection agent, which is it's a daemon set. So there's a pod on each node. And so whatever node this dedicated game server happens to be on is allocating or sending its logs to that agent. So that's automatically taken care for me, which is great. So I don't have to necessarily do anything about logging. I get it for free. So I have a persistent volume claim, and then I have like an external IP address that's associated with that. So I can kind of put DNS in front of it. So like minecraft.noobshack.com would be how you connect to the Minecraft game server. You have the port like 25565 for Minecraft, but that's an example. So there's several components that are involved to kind of create a game server resource type. So those are kind of all codified. And then there's Kubernetes resources that I use for that. And then that is like one isolated unit. And so if users connect to the front end, then they kind of just receive various information from a cache that I have here. And that's mostly like player statistics, latency, if there's leaderboards for how well you're doing on the server, things like that. That's all kind of loaded from a cache that is managed by the backend API. Sorry, I skipped that. Let me go back. And then the backend API itself is kind of just like a server that players don't really necessarily connect to, but game servers are constantly talking to it. And that backend API sends data to the database. So if I want to record a player score count, I can send that and then persist that in the database. And if I want something that's like going to be cached or something that I want to pull up frequently, like current player count, I want to cache that value for a certain period of time and then refresh that value so it's kind of near real time. Generally, I have my player cache on like 5 minutes. So every 5 minutes it refreshes. It's better to cache that and then instead of rewriting a value in a database every 5 minutes, right? And then for the data flow, I kind of went over that a little bit, like stats and player profiles are retrieved from this cache here. And then that's all maintained by the backend. Backend, game servers send data to the API. And then API does periodic queries on servers. So whatever game server query that the server is using, like Minecraft has its own, all the source dedicated game servers have their own like source query, and then Risk of Rain 2 is using a different query. So there's all different various ways of getting information from the servers, all done differently, but it's kind of abstracted to be the same kind of like structure and format, data format. And then all of that, as mentioned, is just kind of stored in the backend. So I have various games that are supported: Counter-Strike, Global Offensive, Mortal, Valheim, Rust, Minecraft, Risk of Rain 2. This can be expanded, but these are the games that I've enjoyed over the past few years, and I've been able to port to Docker and like containerize them and host them on this workflow. And then as of right now, as of speaking, Valheim, Rust, and Minecraft are all playable right now. Cool. So instrumenting with Honeycomb. So how do we get more information about what's going on in the infrastructure? How do I monitor or gain insights on what's going wrong or what is happening on these servers that I've just mentioned? So for V1, for me, it was very easy. I had a Kubernetes cluster. I just wanted to do getting everything from that cluster, sending to Honeycomb, and then what can I do with that data? So we have a Honeycomb. We have a open source Honeycomb Kubernetes agent that you can download. It's just a bunch of Kubernetes manifests that we have like a quick start example that you can just go ahead and run on your Kubernetes cluster. And that will create like a service count, cluster role bindings, config maps. Most importantly, it will create a daemon set, which will create one pod per node. And this will be the Honeycomb collector and most of the logs from those specific nodes. All the pods from the specific node will be sent to the Honeycomb agent on that specific pod and then shipped out to Honeycomb. And then you'll have to have a secret which contains your Honeycomb API key. And that's how you confirm that it's going to your account. And this is just a chart here kind of going over, this is lifted directly from the Honeycomb Kubernetes Agent GitHub. This goes over how the log files are stored and shipped out to the agent. So you can see a pod, a collection of containers. They're just recording standard out, and then it's being logged on the file system under var log pods, and then you have your pod name. And then all these files, container name 1, 2, if you have like rolling logs, those will be then shipped off to the agent. So it's essentially aggregation of logs and then sending off those logs to Honeycomb, but at the same time, it's still recording Kubernetes metadata about this pod and container statuses and things like that. And we'll get into that further later. Cool. So what are some of the types of data that we're collecting using the Honeycomb Kubernetes agent? And then so I kind of mentioned there was like Kubernetes labels that we can kind of all the resources that are labeled, we can kind of aggregate or filter through those using those label selectors. There's Kubernetes metadata. There's Kubernetes resource status. So if I want to check how often a pod has been restarting over a certain period of time, that status is then in the Kubernetes. It's extracted from Kubernetes, uploaded to Honeycomb, and then I can kind of figure that out. We'll see a graph of that later. And yeah, so there's a bunch of data we can delve into. And then some of the features that I like about the Kubernetes agent, myself, like there's event sampling. So if I only want a percentage of the events that I'm sending from Kubernetes, maybe I want like every hour, I only want 20% of the data. You can kind of you can create a sampling specification and then add that to your configuration. And then you can kind of have that amount of data flow into Honeycomb instead of overwhelming it with a bunch of traffic. You can omit containers. So if I have a pod that has multiple containers within it, say I have like some game server and it has a sidecar that does some initial bootstrapping or pre-world creation, and I don't want to collect any information about that pod specifically, I can omit it. So there's a config that I can write to specify, okay, this is a deny list. These are the pods in my infrastructure that I do not want any metrics from or any information about. Please omit them. I think that's pretty interesting. So as far as like using the Honeycomb Kubernetes agent yourself, you just need to sign up with Honeycomb, create a Honeycomb team, get a Honeycomb API key, and then deploying it to your Kubernetes environment of choice. I use like a managed Kubernetes environment, GKE. There's EKS, there's self-hosted, Azure has its own offering, and then there's several third-party Kubernetes providers out there that you could use this on. So yeah, the quick start example is a great way to get started, and then you can productionize and create a version that suits your use case based off that. Cool. So now we're going to go into deploying the servers. So the architecture I showed earlier, how do we actually get the servers into Kubernetes so that all of those components can interact with each other properly? So I have pretty much like a very simple 3-step process that I take for my personal infrastructure. So I code whatever changes I need to make. I'll make sure I define it as code, and there's a PR in GitHub staged and ready for commit. Pretty much once that's ready, that's when my automation starts, and I'll create I'll do a buildable based off that PR. And then once that is merged, then I will actually get like additional artifacts. So I'll like create a container image, and then I'll kick off another process that will stage changes to my Terraform code, which allows me to deploy to Kubernetes. And I'll break that down on the specific tools that I use in the next slide here. Cool. So this is like a little graphic of what exactly I do. So as I mentioned, I have, let's give another example. I've been using Minecraft, so let's continue with that. If I want to change something simple, let's say I want to double the player size on my Minecraft server. All I would have to do is get a PR, kit my changes, and all this would be like a simple Kubernetes manifest config map change, really. I would just change the player limit from like say 30 to 60. And then I would create a PR. I would submit that PR with the YAML changes and merge it. I have another process, since my game server container binaries and my configs are hosted in the same repository, it would then do a new build for that specific PR, though there's not actually much changing with the container itself because I'm changing a config setting, but it does update all of the Java prerequisites and updates to the latest Minecraft server. So there is some use in creating a build without having any changes to the Docker file or anything on the container side, but it's just an automated step, part of my process. And if I wanted to, I could overwrite that and just use a older build or something like that. So I could skip that step. But after the container is built, I deploy everything through Terraform. So pretty much what I would have to do here is, since I host everything as a Kubernetes YAML manifest, I have a tool that I use, K2TF. It's open source on GitHub that converts Kubernetes YAML into HCL, HashiCorp language that can be read. So read by Terraform. So I manage everything through Terraform. Those manifests are then rendered into Terraform. and that contains all of the information that I need to deploy. There are some Terraform variables that I have to manually add to the specs, but I do have some automation, like using sed and stuff like that, to automatically insert those variables, like the container tag and the host, the service IP addresses that I use within Kubernetes. Those two things are inserted through kind of like some additional automation. And then once I do a Terraform plan, I see all the resources. So in this case, if my Minecraft server, it would say change to the config map, and then really nothing else, since the stateful set, the PVC, the service, all the other components are already in place since the server is running right now. I would do that one change, update the config map. So Terraform apply, it changes the config map. And then that would allow me to be ready. We'd all be deployed on Kubernetes, and we could just start playing as soon as that Terraform apply is done, which is great. It would be like a 1 to 2 minute, maybe up to 5 minutes for the world to reload from its PVC, because the container would shut down and then recreate itself. So the spin up time is just how long it takes for Minecraft server to load its world. And potentially I would need to pull the newest Minecraft image if I had chose to do that. So there's a little bit of delay, but within 10 minutes, it's online, which is awesome. Compared to like old school, when I used to do it, it was, if I had to take down a server, I'd have to rebuild and do everything manually. And that would be 4 to 5 hours to get one server online, which was much rougher. Cool. We're going to go to the next slide here. So here's some examples. I've been talking about Minecraft a lot, but as we've talked about in the Minecraft example, if I wanted to do a small config change, it's relatively simple. It's a persistent world, so all the resources are kind of just in my cluster running there forever until I want to do something with it. So that's kind of just no hands-on ever since I've kind of created that world that's been running. Valheim, every now and then. So in Valheim, there's a victory condition. You can defeat all the bosses in the world, and then that kind of makes, you can still explore the world of Valheim, but there's just less content, less things to do because the progression thresholds have already been hit. So every now and then I will want to do a conditional reset. So this is a very manual, like I've identified that the server is completed or the game has been finished, and then I will manually go in, recreate a new seed, and then regenerate a new world. So I'll delete most of the stuff back up and then delete most of the stuff on the persistent disk that had all of the player state. And then that will, I guess, world state, and then that will be regenerated. And then thirdly, I have a different type of example here for Rust. Every week I do reset this because that's kind of generally how Rust servers go. You want to do a very frequent reset so you can reset the world, and all the prefabs and all the players can kind of go from none to great throughout the process of the server lifecycle. So like during Rust, that'll be like every Thursday for me. I will like generate a new map, generate a new seed, update the leaderboards. I have some scripts to kind of parse information about player statistics and then send that all forward. And these are kind of like 3 different real life use cases that I use. And I wanted to get more insight into like all of these steps. So instrumenting Honeycomb allows me to kind of get a little bit more information about, or at least now I have the ability to start tracking my deployment timers and then seeing all these various deployment use cases and ensure that they're running smoothly. So like Minecraft, for example, I said like it could be up within less than 10 minutes. Now I can actually start adding markers. The next time I do a full Minecraft deploy, I can see start time, stop time, see it very easily in Honeycomb. So it's great. Lastly, we're going through the observe section. So finding information about our servers and what questions should we ask about how to improve game server performance here. So I have a few questions that I wanted to like find for myself, like what are my resource usages based off player activity? So when I have players near, or if a server is near full, what does that look like over the time the server is near full versus when the server is empty versus when the server is at half capacity? So doing a lot of like different comparisons based off resource availability and resource usage, and seeing how I can fine tune and allocate the correct resources for my specific type of server. Identifying latency, since I host everything in like the US Central region, I wanted to see if I could find, if I initiate a connection from US West or from elsewhere in the world, if I can find player latency issues, and then also latency in if like the server hangs or something like that. This is a tricky question because there's a lot of different ways for each different type of game to identify latency. But I have some rudimentary ways on identifying this in my case, but there's, I guess, more to expand on in that case. And then, as I mentioned earlier, metrics in relation to player load. So that's server empty versus server full. What does that look like? Cool. And this is going back to kind of installing the Kubernetes agent for Honeycomb. You get a bunch of information just out of the box just by having those Honeycomb collectors there. So metadata and metrics, you get resource statuses about those various Kubernetes resources. And then you have label selectors in place, and you can use those, especially for like doing matching or where clauses in our query, data query builder. So I can just go over this real quick. Yep, so we've got the Kubernetes indicator, and then we have cluster name, like a bunch of name about all the resources. And then we have statuses. So these are more so like Kubernetes statuses, like if it's restarting, restart count. So this would be like a pod restart, and then this would be restart count over its lifetime. Restart delta is also kind of nice to have. And then we do get like Kubernetes event messages here too. And then the active phase that it's in for whatever status, which is cool too. I'm glad it adds that. And then all the labels, most of these, I just use like app. Most of these are kind of Kubernetes metadata and other ways to kind of aggregate information. So they're all useful, but I mostly just stick with the app because I want to query by my specific game server type, and all of them are labeled that way under app. Metrics, and then here's some of the metrics that you can get. So you can see you have CPU, file system, memory, network. So these are some good ways you can identify things going on within your Kubernetes container platform and traffic between your interconnected services. Cool. And then lastly, this is just like a super basic query that I have used a few times, but it's like kind of like not necessarily brute force, but it's just like a way to show a bunch of information about, like, at a high level, going back 2 slides, like finding the like the player statistics based off, or sorry, server statistics based off player availability or player usage, or sorry, player count, I should say. Here I have like my query is just a min-max on CPU usage and memory usage, and then I want to count distinct restart times. So if my container is failing for some reason or something's going on within Kubernetes, I want to keep track of that. Those were things that like were pretty, like when I was doing deploys, this was useful for me. All my game servers are hosted in the default namespace in Kubernetes. And then I group by the pod name. So you can see here, it's like Valheim, Minecraft, and some of the other game servers and other services that support that are there. And then I'm ordering by minimum metric CPU usage. So I see this column. And then, yeah, so we can see a few charts here. I guess the charts are kind of small in this case. And then we can see like where I was looking at as far as deployment goes. But at least in count distinct, the fact that I see this chart here, we can see a bunch of restarts going on for one server. So this would be something that I need to diagnose. So I just mouse over this. Actually, we can see since it's green, it correlates with this green Rust PVP here. So this means like my Rust server is actually having issues at a glance, right? Because it shouldn't be restarted and it should be just running persistently. And similarly up here, we'll see this status.restart is just 1, referring to it is actively restarting, and this is the count of restarts it's done over a period of time. So this is some ways that I'm able to figure out deployment issues, and if I need to do server tuning or increase resource usage. So this at a glance helps me do that. And this is where I want to go next with instrumenting Honeycomb. So I have 2 other services that are mentioned in the architecture. So we have the API and the front end. Those both would need to have the Honeycomb SDK implemented. So the front end is written in JavaScript. So we have like a Node.js, libhoney.js that can be integrated into the front end. And then that way I would be able to capture more detailed things about the functions that I'm writing. So like page load times, if I wanted to do a server statistic like a game server statistic display page, I can have a trace on how long that's taking to interact with the cache, populate that value, display the value on the site. I can get more insights there. And then on the API side, if an endpoint's being called, how long does it take for the endpoint to be run? How many times is it being run, by who? And then I can do some cool thing about cache stat tracking to ensure that my cache is working properly. I can do like some counts or have like a trigger saying if cache was not refreshed in last X period of minutes or hours, like raise an issue because that should be a behavior that I want. There's things I can do later on with these. So it would mostly be through libhoney.js, and then there's the Golang SDK as well. So since my API is in Go, I can easily implement those both into my softwares, and then I would have full coverage of all of my services, all the game servers that are running on Kubernetes, and I could have all of that data either in one data set or multiple data sets, and I could use those pieces of information to kind of collectively to kind of get multiple points of, okay, this server is having an issue, let's delve into it even further. So that would be awesome for me. And then next steps after that is like CI, CD, like the deployment pipeline that I mentioned earlier, integrating Honeycomb metrics or like deployment markers, or using some like Honeymarker, for example, using those things within my deployment process to figure out how long it takes from deployment to actually playable. That would be really cool. And we can do some more things as well. Like, as I mentioned, like the API and front end can also be integrated. So these things are not present in my infrastructure at the moment, but that's next step for sure. Yeah, so that's pretty much all I have to go over instrumentation with dedicated game servers using Honeycomb, mostly focused on the Kubernetes agent. But hopefully this gave you a good overview on how you can implement this into your Kubernetes infrastructure. And then maybe you have some thoughts in your mind going over like, oh, what questions can I start asking Honeycomb to get more information about how my system works? Yeah, so for more information about me, check me at rulan.com, rulan.com. All my stuff is there. Check out Honeycomb. Thank you for Honeycomb and everybody at Honeycon. Appreciate the event. It's been great. Yeah, thanks everybody.
Thank you, Michael. That was great. Yeah, we'll just jump right into the questions because we're going to have to move over to the main stage pretty quick here. But we had one question in Slack, just wondering, are you still using things like metric server or Prometheus, or is just all of this going straight to Honeycomb from Kubernetes?
Yeah, so using the Kubernetes collector, I have that installed. So there's a daemon set that runs on each node within the Kubernetes cluster, and then that pretty much manages shipping all of the information associated with the Kubernetes pods and cluster to Honeycomb itself. So besides the Kubernetes collector, I don't use anything else within the infrastructure.
Wow, that's great, cool. And I'm curious because, like, you know, Honeycomb's known really for like our event support more than our metric support, but we clearly do have metric support even beyond, you know, what we announced earlier today. So what was your experience using Honeycomb for metrics? Is that really much different than kind of the event use case?
So in my case, I wanted to have the additional events and like traces as well. So it's kind of like what I expected to use with standard metrics. I had the same kind of tools and some, I guess, nicer ways to visualize it. And using the query builder, I was able to kind of access some of these familiar queries that I would in other systems, but just through the familiar Honeycomb UI.
Yeah,
so it was a good experience overall.
Yeah, right. So it's got all the tools you need, but now it's all in one place. You don't have to kind of keep jumping back and forth between places.
Right. So that's a big thing for me, just having a source of truth and like one tool to rule over essentially.
Right. That's awesome. Cool. Well, thank you again. And thank you to all the folks who presented here on the Mystery Solved track at Honeycon, Frank Chen, Michael Erickson, Glenn Mailer, and Michael. And, you know, drop in Slack, give them some love, and then we're going to move our way over to the main stage. So join us over on the main stage, and this stage is now going to be closing. Thank you.
Thanks, everyone.